If you've seen these same sound wave questions pop up again and again in your WAEC or JAMB paper, you are not imagining it. They are real, and today we are solving all 57 of them for good. Welcome. You have just made one of the smartest clicks today. This isn't another theory dump. This is the Triune method in action, where every formula is broken down, every parameter explained, and every memory hack served hot. Ready to turn past failures into flying colors? Let's dive into question 1 and master the physics of sound once and for all. Hello guys, welcome. This is a quick solution to a problem under sound waves for JAMB candidates. So let's assume that this question comes this way. But remember, this is a derivation. So derive the formula for speed, which is V of sound, in solid materials, okay? In solid materials. Are you here? Now, you might use this formula to solve problems, but they might not ask you to derive. But you need to know how to derive this formula by using formula analysis to find the relationship between let's say velocity, which is V, E, which is Young modulus, and density. Are we here? Now, we want to show the relationship between V, E, and P. So where V is the velocity of sound in solid materials, then E is the Young modulus, and it has to do with solid materials. Then density is also here. So solution: for us to prove that the formula for Young modulus will give us velocity of sound in solid materials, we need to follow this process. So if V is equal to the square root of Young modulus over density, then what formula can we use to show this relationship? Please note that you can use dimensional formula to show the relationship. For the sake of this tutorial, we are going to use the formula of Young modulus to connect to this velocity is equal to the square root of Young modulus over density. I hope you are following. So let's begin. We want to show the relationship now. After this, we are going to solve a mathematical problem. JAMB question will be solved. Please stay till the end. Recall that Young modulus E is equal to stress over strain. Recall it is tensile stress over tensile strain. Okay? Now, E in short form will now become force over area, all divided by extension over length. Now, this is the interpretation of the formula above. Stress is force over area, while strain is extension over length. Take note of that. So that E is equal to F over A divided by E over L. Are you here? Now, we want to connect this together and bring in velocity and also bring in density into this. Now, recall that force is equal to mass multiplied by acceleration. Are you here? Next. Now, also recall that density is equal to mass over volume. Are you here? Mass over volume. So we want to cross multiply, make mass the solid formula, so that mass is equal to density multiplied by volume. I hope you are following. We'll substitute that into the formula of Young modulus. Are you here? Let's proceed. Therefore, Young modulus E is equal to, for our force, we have mass times acceleration. So let's rewrite this as F over A times L over E. we have inverted this place by converting division sign to multiplication sign. So E is equal to mass multiplied by acceleration multiplied by length, all divided by area multiplied by extension. I hope you are following. Multiplied by extension. Please take note that we have inverted the other part. We've changed division sign to multiplication sign, and hence L becomes the numerator and E becomes the denominator. So this will give us Young modulus is equal to density multiplied by volume for mass. I hope you are getting this. Mass is density multiplied by volume. So we've substituted for mass. Then this V is not velocity. Please take notice. Volume multiplied by acceleration multiplied by length, all divided by area multiplied by extension. Are we together? Now we can reduce this. So Young modulus is equal to, recall that you have density here and we have volume. Volume can be able to cancel our volume. So we are going to manipulate our denominator, which is area multiplied by extension. They are all products of length. So area is length times length multiplied by another length, which is extension. So you see that this will give us 3 dimensions of length, which will equal volume. I hope you are following. So A times E will give us V, which is volume. Please, we're going to do that now so that you can see. But E is equal to a component of length because it is measured in what? In meters. Hence A, which is area multiplied by extension, will equal volume, because this gives us 3 dimensions of length, which we call volume. Take note of this. So by substitution now, we now have Young modulus E is equal to density multiplied by volume. Okay, let's write it in full. Volume multiplied by acceleration multiplied by length, all divided by A times E is volume, so all divided by volume, so that volume can cancel our volume. Then we now have Young modulus E is equal to density multiplied by acceleration multiplied by length. Are you following? Then also recall, but A, which is acceleration, is equal to velocity over time. Note that this change in velocity, please, which is V over T. Are we together? So we'll substitute that into this formula now, so that our Young modulus E, okay, our Young modulus E will now equal density multiplied by V over T multiplied by L. Are you here? Then also recall that the formula for but L is equal to length, and length is in meters. Okay, likewise distance is also in meters. So we can now replace L with distance. Hence L is equal to D. Let's proceed. So that Young modulus E is equal to density multiplied by velocity multiplied by, let's isolate now, L over T. Okay, but note that L is distance. Okay, so L over T is equal to V. I hope you are following, because the formula for velocity is distance over time. Are you here? But L over T is equal to distance over time and is equal to V. So we'll substitute E is equal to density multiplied by velocity multiplied by velocity, so that E is equal to density multiplied by velocity squared. Our goal is to make V the subject of the formula, so that we can isolate V by dividing through by density. Okay, so that density will cancel out density. Then V squared will now equal Young modulus E over density. So take the square root of both sides so that V is equal to the square root of E over P. Young modulus over density. We have successfully shown that the formula of Young modulus can be used to derive the formula for speed in sound when it comes to solid materials. Now let's solve a mathematical problem, and this JAMB question, please. Now let's solve this JAMB question, okay, under sound waves. We want to put the formula above into use. So given that Young's modulus for aluminium is 7.0 times 10 raised by 10 Newton per meter squared, and density is 2.7 times 10 raised by 3 kilogram per meter cube, find the speed of the sound produced if a solid bar is struck at one end, okay, with a hammer. So this is how the JAMB question looks. So we're going to solve that now. Solution. Let's extract the data. Given the Young's modulus, so our Young modulus E is equal to 7.0. So let's write it out. 7.0 times 10 raised by 10 Newton per meter squared. Then our density is given to be, so let's represent that density, okay, density is equal to 2.7 times 10 raised by 3 kilogram per meter cube. Now we're asked to find the speed, so we're going to do that. We could do justice to that. So find the speed. V is equal to unknown. What formula are we going to use here? The formula that we've proven above. So we're going to use that formula now so that we know that V is equal to, using V is equal to square root of Young modulus over density. We now have V by substitution is equal to square root, let's draw it this way, square root of 7.0 times 10 raised by 10 all divided by 2.7 times 10 raised by 3. Now if you do this, you see that V is equal to, okay, our calculator will give you V is equal to 5091.75. So if you write this in standard form, you have V is equal to 5.1 times 10 raised to the power 3 meters per second. So this is the solution to this problem. I hope you've learned one or two. This question is JAMB question under sound waves using Young modulus. Hello guys, here's a question under sound wave. A note of frequency 2000 Hertz has a velocity of 400 meters per second. What is the wavelength of the note? The triune components, the frequency, the velocity, the wavelength. Are you here? So solution. What are the given parameters or data? The first is the frequency of 2000 Hertz. So we're going to represent that using lowercase f is equal to 2000 Hertz. Has a velocity of 400 meters per second. So our velocity is 400. So V is equal to 400 meters per second. Are you here? Then wavelength. What is the wavelength? The third triune component. So the wavelength is represented by lambda. This is a symbol. So it's unknown. Now we want to begin to solve this properly. Let me refresh your memory. Recall that you've been taught that velocity is equal to distance over time, and also that frequency is the inverse of period. If you connect these together, then you have V is equal to F lambda. Are you following? Join us when we shall be treating this topic properly. So you can see that your F is substituted for T and it becomes 1 over F. I hope you are following. So if you do that, your V will equal F lambda. Lambda and distance are the same because they are both measured in meters. So if we are making lambda the subject of the formula, then we'll divide through by F. Are you here? So that V is equal to F lambda, divide through by F. Then if we do that, F will cancel out F, leaving lambda alone. Hence, lambda is equal to V over F. We can now substitute and say that 400, okay, all divided by 2000 for frequency. So 2000 is equal to, if you do this, to give you 400 divided by 2000, 0.2 meters. Thank you, and join us for the next question. Hi, welcome to this channel. Here's another question on the sound wave. The velocity of sound in air at the sea level is given to be 340 meters per second, while that of light is 300,000 kilometers per second. How far to the nearest meter from the center of a thunderstorm? Thunderstorm is an observer who hears a thunder 2 seconds afterward, after a lightning flash. So this is a question before us, and remember the triune components are velocity, is also the distance, and then we also have time given. So let's solve quickly now. The sound and the light are two different components here. So we have component 1 to be sound, component 2 to be light. Are we together? So basically this question will be centered on the sound. Are we here? So the velocity, let's begin now. Let's pick our data, our parameters. The velocity of sound. So V of sound is given to be 340 meters per second. So we represent that as V of S. Are we here? Is equal to 340 meters per second. Then what again is given? Velocity. Are we here? Velocity of light in air is 300,000 kilometers per second. So write that. We might not need it, but we'll still go ahead to write it. V of L is equal to 300,000 kilometers per second. Are we here? Then what again is given? If you observe from this question, it reads how far. How far is talking about distance, which is wavelength in other term. So our distance here is given to be unknown. Okay, then what again is given? The time is given, the time to hear the sound of the thunder. So our T is 2 seconds. Are we here? T is 2 seconds. So solving this using a regular formula, the very known formula that says that V is equal to distance over time. Okay, distance over time. Let's make distance the subject of the formula once and for all. By cross multiplying, you have D is equal to VT. Are we here? So we can now substitute that into this. D is equal to VT, and our D is equal to V is 340 multiplied by 2 seconds, so that our D is equal to 680 meters. Are we together? If you observe, you see that we didn't make use of V of L, which is 300,000 kilometers per second. Why? Because the question here concerns the sound. The observer hears a thunder, so it has to do with the sound, not the lightning flash itself. Are we here? So the area of concentration is the thunder, and which is why at this point we did not center or use VL. Are we here? Because it's also constant. So thank you. Join us for the next question. Connect. Guys, here's another question. The velocity of sound in air will be doubled, underline doubled, if its absolute temperature is given to be unknown. So solution. What are the given parameters from here? Velocity of sound in air will be doubled, but you need to know the initial velocity, which is V is equal to V. Since it's doubled, you will now say that we have 2V. Is that clear? Then recall that the absolute temperature is given to be theta is equal to unknown. Are we here? So with this, but recall or remember that V is equal to the change in V. Then we also have change in theta, delta theta. Okay, so that our parameters now given theta, if you check it, you see that we have V1 to be V, then we have V2 to be 2V doubled. Are you here? Then our theta 1 is theta, then our theta 2 is unknown. Now let's refresh our memory. Recall that velocity of sound in air and temperature are related. They are directly proportional to each other, but V is proportional to the square root of theta, which is temperature. Are we together? So by expansion now, you know that V is equal to K square root of temperature. Is that clear? So we're going to ignore our constant K, so that V is equal to the square root of temperature. Hence, let's write our formula properly. V1, okay, is equal to the square root of theta 1 over V2 over square root of theta 2. Is that clear? Now let's substitute. By substituting into the formula above, then you know that our V1 is V divided by V2 is 2V is equal to the square root of our theta 1 is theta, okay, square root of theta, all divided by theta 2, which is the square root of theta 2. Theta 2 is unknown. That's what we are looking for. Is that clear? So cross multiplying now, what are we going to have? If you cross multiply this, you now have V multiplying the square root of theta 2, okay, and is equal to 2V times the square root of theta. I hope you are following. 2V multiplied by the square root of theta. So we are looking for theta 2. So let's divide through by V. Divide through by V. So if you do that, V will cancel out V. Then our square root of theta 2 will equal 2V multiplied by the square root 2V multiplied by the square root of theta, okay, all divided by V. So but remember, we are looking for theta 2, not the square root of theta 2. So let's square both sides. If we square both sides, then we have theta 2 left is equal to 2V multiplied by the square root of theta all over V. Then we square everything. I hope you are following. Then let's begin to expand it. So V will cancel out V. Are you with me? So that theta 2 is equal to 2 squared. Are you seeing that? 2 2 squared multiplied by theta, because this square will cancel out the square root you are seeing. I hope you are following. Please. Then our final answer becomes theta, which is theta 2, is equal to 4 theta. I hope that is clear. Thank you. Alright, here's another question before us. A note of frequency, underline that, 200 Hertz, has a velocity of 400 meters per second. Calculate the wavelength, triune component, frequency, velocity, wavelength. So solution. Given data include our frequency to be 200 Hertz. So we're going to write F is equal to 200 Hertz. I hear F is equal to 200 Hertz. Then we're given velocity to be 400 meters per second. So our V is equal to 400 meters per second. Then we're asked to calculate for the wavelength. So our lambda, which is the same thing as wavelength, is unknown. Solution now, as we continue using the formula, V is equal to F lambda. Are you here? Then lambda will equal V, okay, V over F if you divide through by F. I hope you are following. So let's substitute this now. Our V is 400, so 400 divided by our F is 200. So we'll write 200, so that you now have 4 by 2 will give you 2. So our final answer becomes 2 meters. Are you here? 2 meters becomes our final answer. Another question here before us. A boy standing some distance from the feet of a tall cliff claps his hands and hear an echo 0.5 seconds later. So the question is, if the speed of sound is 340 meters per second, how far is he from the cliff? Triune components, we have time, we have velocity, we are now having distance. Are you here? So our given data from this question, let's extract them now so that we can solve this question properly. So let's begin with time, which is t is equal to 0.5 seconds. Okay, then our speed is also given to be 340 meters per second. So we're going to write V is equal to 340 meters per second. And then how far it denotes distance is unknown. Are we here? So our distance here is unknown. Since we are dealing with sound, we are using D for distance, not S. Okay? Now, recall that this man hears an echo. So using V is equal to 2D all over T. Are you here? This is gotten from linear equation of motion. Now, our echo has to be heard. So we must factor that into consideration. So let's depict this using a diagram. So if this is the boy and this is the tall building, okay, the boy is standing a distance from a feet of a tall cliff. He claps his hands. So you see the distance. It has to be to and fro movement. Are you here? So we have D from the boy to the tall cliff, then D from the cliff to the boy. So D is equal to D. Hence D plus D is equal to 2D. So let's use 340 is equal to 2d all over 0.5. I hear 340 is our velocity. You can see that is given to us. Let's cross multiply now, so that we'll have 340 multiplied by 0.5 will equal 2d. Are we here? From here, 340 multiplied by 0.5 will give you 170 is equal to 2d. Divide through by 2. 2 cancels out 2. Then d is equal to 170 by 2 will give you 85 meters. Thank you. Hello guys, here's another question. A man standing 300 meters away from a wall sounds a whistle. The echo from the wall reaches him 1.8 seconds later. So the question is, calculate the velocity of sound in air. So the triune components from here, we have our velocity, we have our time, and we have our distance. So, but from this question, we have our distance to be d is equal to 300 meters. Are you here? So our d is equal to 300 meters. Then we have our time to be 1.8 seconds. Are you here? Then we have our v, which is velocity, to be unknown. So calculate velocity of sound in air. Hence our v is equal to question mark. So let's interpret this using a simple diagram. So let's assume that this is the boy, okay? The boy standing in front of a building. So let's assume this is a building. Now you can see the distance between the boy and the wall. Are you here? So the distance is given to be 300 meters. I hope you are following. The echo from that wall, from this building, reaches the boy 1.8 seconds later. So our distance is 300 meters. That is from the boy to the building. Is that clear? Then we are asked to calculate the velocity of sound in air. In case if you are asked for the echo, of course you know that this 300 will be equal to another 300. I hope you are following, because we are referring to echo. Okay, so let's solve this properly now. We are solving using v is equal to 2d over t. Then automatically we know that our v will equal v is equal to 2 multiplied by 300. So we have 2 times 300, all divided by our t is 1.8. So all divided by 1.8. So that this will equal 2 multiplied by 300 will give you 600 over 1.8. Our final answer becomes 333.33 meters per second. Thank you. Next question. A man stands in front of a tall wall and produces a sound. If he receives the echo of the sound 2 seconds later, so we are asked to calculate his distance from the wall. So the speed of sound in air is given to us to be 330 meters per second. Are we here? The triune components, of course, you have velocity, you have time, you have distance. Okay, this is echo under sound problem. So with this, let's extract our data. We have our t to be equal to 2 seconds. Then what again is given? Calculate the distance. So our d is equal to unknown. Are you here? Then what again? Our speed is 330 meters per second. So v is equal to 330 meters per second. Are we together? So if we depict this using this illustration, the boy, the wall, distance from the boy to the wall, and then from the wall to the boy, you see they are the same. So from the boy to the wall is D. Are you here? Then from the wall to the boy is also D, because they are equal to each other. So we have D and D. Are you here with me? So quickly, let's solve for our D now. Recall the time from the boy to the wall is given to be 2 seconds. Okay, the time for the echo. Are you here? So using V is equal to 2D over T. By substitution, we have 330 is equal to 2D divided by 2. Cross multiplying, we have 330 times 2 is equal to 2D. 330 by 2 will give you 660 is equal to 2D. Divide through by 2 so that our D is equal to 660 by 2 will still give you back your 330. So our final answer becomes 330 meters. If you have questions, you can drop them in the comment section below. Thank you. Next question. A sound note of frequency 250 Hz and wavelength 1.3 meters is produced at a point near a hill. If the echo of the sound is received, are you here? Is received on second later at the point, how far away is the hill from the point? That's the question. The triune component solution, let's extract them, are given datas. Number 1, we have our frequency. So our F is equal to 250 Hertz. Are you here? Then our wavelength, number 2, component. Lambda is equal to 1.3 meters. Then our number 3 component is time. And our time is given to be 1 second. Are you here? So we're going to solve this question because they are asking us how far away is the hill from the point. So we're looking for D. D is unknown. Are we together? So let's depict this. Imagine this is the wave. It is a transverse wave. Let's introduce this. Our vertical axis. Okay? Yes. Then our wave moves. Can you see that? It travels from the point of origin. So, and that's the point of termination, which is the wall. Okay? Where the echo was received by the man. Our D is represented. Can you see that? So that if we use V is equal to F lambda to find V, and V, okay, is equal to 2D over T to find our D. So we're going to carry out 2 steps here. I hope you are following. So let's begin. V is equal to F lambda, so that our V is equal to our F is 250 Hertz. So we have 250 multiplied by, also our lambda, our wavelength is 1.3 meters. So multiply by 1.3. So that V is equal to, this multiplied by 1.3 will give us 325 meters per second. So we can now pick the value of V and substitute into the second equation, which is V is equal to 2D over T. So V is equal to 2D over T. By substitution, we now have 325 is equal to 2D over our T is given to be 1 second. So we have 1. I hope you are following. Then we'll cross multiply from here so that 325 is equal to 2D. Divide through by 2 so that our D will equal 325 over 2 will give us our final answer to be 162.5 meters. Next question reads, a sound note is produced by using a ringing bell, and the echo of the note from the nearby wall is received. Are you here? 0.5 seconds later. So if the frequency of the note is 400 hertz and its wavelength 1 meters, then calculate the distance between the bell and the wall. Are you following? So solution, let's extract the given data using the Triune method for better understanding. Are you here? So the first, our time is 0.5 seconds. So let's pick that time. T is equal to 0.5 seconds. That is the number one triune component. Then the second triune component is the frequency. Are you here? So our F is 400 hertz. Then the third triune component is the wavelength, which is lambda. So lambda is equal to 1 meter. Now recall that distance is also related to wavelength, which is distance. Hence, our D is unknown. So this triune component or method will help you to be able to recall the formula that is related to your problem or question. So using V is equal to F lambda to calculate for our velocity, and also using V is equal to, are you here, 2D over T to solve for our distance. Then we can begin by saying V is equal to F lambda, so that our V is equal to 400 multiplied by 1, okay, which gives you 400 meters per second. Are you following? So that we can substitute this into V is equal to 2D over T. Are you here? So let's do that now. V is equal to 2D over T, so that 400 is equal to 2D over our time is 0.5 seconds, so that we cross multiply. Then we have 400 multiplied by 0.5 is equal to 2D. Okay? Please drop your questions if you have any, or if there are confusions. Are we here? So please, let's proceed with these. So for you to obtain D now, we need to divide through by 2, so that 2 cancels out 2, and our D is 100 meters. I hope this was very clear. Do subscribe to our channel for more. Next question. A pulse of a sound is transmitted from a ship, and the reflection from the seabed, here, is recorded after 0.2 seconds. The question is, calculate the depth of the sea. So we have to take speed of sound in sea water to equal 1560 meters per second. So solution, using the Triune method, let's extract our data. Number 1, our time is given. So time is 0.2 seconds. Number 2, Triune component is the depth of the sea. Are you here? So it gives us the distance or the depth, since it is based on reflection. So we have our D to be unknown. Then number 3, we have the speed to be V is equal to 1560 meters per second. Are we here? So for us to be able to calculate this, we use V is equal to 2D over T, so that by substitution we have our V, okay, which is the same thing as 1560 is equal to 2 multiplied by D over 0.2, so that we'll cross multiply from here. And when we do that, we have 0.2 times 1560 is equal to 2D, so that we say that 2D is equal to 0.2 multiplied by 1560 will give you 312 divided by 2, all true. You have d is equal to 312 over 2 will give you 156 meters. Next question before us reads, a goal stands 80 meters away from a tall cliff and blows a whistle. So if the speed of sound in air is 330 meters per second, then how long would it take her to hear the echo of the sound? So solution using the Triune method are given data include: number 1, we have the goal standing 80 meters away. So this represents the distance, okay? But let's represent that using a diagram. So let's depict that. If this is the goal, then let's represent the tall cliff. So this becomes the tall cliff. Are you here? So the goal is standing 80 meters away from the tall cliff. So we have a distance here to be 80 meters. Remember, the question is specific about the time. How long? Okay? But recall that this has to do with echo. So the sound has to move from the mouth of the goal to the cliff, then to bounce back or reflect back to her. So our d is 80 meters. Our time is unknown. And then the third triune component that's given is the velocity, which becomes v is equal to 330 meters per second. Are you here? So which formula will suit this now? I think the formula to use will be v is equal to 2d over t, right? Alright, let's try that. Using v is equal to 2d over t, then we substitute and we say that 330 is equal to 2 multiplied by our d is 80 all over t. Are you here? Then let's proceed further now, so that when we cross multiply, you have what? 330 multiplying t, okay, is equal to 2 multiplied by 80. Are you here? So that 330t is equal to 160. So let's divide through by 330. So that 330t over 330 is equal to 160 over 330. So that our t will equal 160 over 330. Are you here? So 160 divided by 330 will give you our final answer, which becomes 0.485 seconds. Are you here? If you have questions, drop them in the comment section below. Next question. A boy stands in front of a tall wall and produces a sound. Okay? If he hears the echo 3 seconds later, then calculate his distance from the wall. Take speed of sound in air to be 330 meters per second. So solution from the given data using the Triune parameters. Number 1, we have time to be 3 seconds. Then we are also given our distance to be unknown. Then recall our speed, which is v, is given to be 330 meters per second. Are you here? So with this, it can help you to solve this problem. Then also recall that using v is equal to 2d over t, we can be able to find d from here. So 330 is equal to, okay, is equal to 2 times d over our t is 3. So that with this we cross multiply from here. hope you are following. Then if we cross multiply, we have 3. Okay, let me rule a line here. We have 330 times 3 is equal to 2D. Please help this channel to grow by subscribing. I hope you are following. So thank you. Let's proceed. 330 times 3 is 990 is equal to 2D. So divide through by 2 so that our D is equal to 990 divided by 2 will give you 495 meters. Thank you. Alright, let's proceed to the next question. How far from a hill should a boy stand to hear the echo of his claps 1.6 seconds later? The speed of sound in air is 340 meters per second. So solution using the Triune parameters, the three interconnected parameters. Number 1, how far? So what is that? The distance is equal to unknown. So number 2, 1.6 seconds later is time, 1.6 seconds. And then we are given speed to be 340 meters per second. So velocity V is equal to 340 meters per second. So we can now use a formula that connects these three triune components. So V is equal to 2D over T. So from here we can substitute 340 is equal to 2D over T. T is 1.6. So 1.6. Let's write that. So that from here we can cross multiply. Are you with me? So when we cross multiply this, we now have 340, okay, multiplied by 1.6 is equal to 2D. From here we can divide through by 2, but before then 340 multiplied by 1.6 will give us 544 is equal to 2D. So we can divide through by 2 now, so that our D will now equal 544 divided by 2 will give you 272 meters. I hope you are following. Please subscribe. So here's the next question. A man stands in front of a high wall and produces a sound. This practical question. If he receives the echo of the sound 4 seconds later, what is his distance from the walls? So take the speed to be 330 meters per second. So let's extract the given parameters using the Triune methods. So the first is time, 4 seconds. Then the second is our distance, which is unknown. Then the third is the speed, which is given to be V is equal to 330 meters per second. Can you see the triune components here? So using V is equal to 2D over T, we can now substitute and say that 330 is equal to 2 times D over 4. So that from here we can cross multiply. Are you here? After cross multiplying, we now have 330 times 4 is equal to 2D. I hope you are here. So please subscribe to this channel for more of these tutorials. 330 multiplied by 4 will give us 1320 is equal to 2D. So we divide through by 2 so that our D, are you here, will equal, our D will equal 1320 divided by 2 will give us 660 meters. I hope you are following. Next question. The echo of a sounder from the bottom of an ocean is heard 2.5 seconds later. If the speed of sound in water is 1400 meters per second, then the depth of the ocean is unknown. Solution. Extracting the triune parameters. Number 1, we have our given data to be time. Our T is equal to 2.5 seconds. Then number 2 of the triune component is the speed. Velocity is equal to meters per second. Then the third of the triune component is unknown. The depth is the same thing as the distance is unknown. Are we here? So let's use a regular formula for this that will connect these triune components together. So using V is equal to 2D over T, then we can substitute for these to say that 1400 is equal to 2 times D over 2.5. Our time is 2.5. So from here, we can cross multiply so that we have 1400 multiplied by 2.5 is equal to 2D. Are you here? Please subscribe to this channel for more of these tutorials. So 1400 multiplied by 2.5 will give you, let's see, it will give us 3500 and is equal to 2D. So let's divide through by 2 so that we can have D to be equal to 3500 divided by 2 will give us 1750 meters. So that is that for this question. Please subscribe if you are new to this channel to get more of these tutorials. Let's proceed further. This question reads, in order to find the depth of the sea, a ship sends out a sound wave and receives an echo after 1 second. So if the velocity of sound in water is 1500 meters per second, what is the depth of the sea? So let's begin to extract the triune parameters. You agree with me that 3 things are common here. So let's begin. The first is in order to find the depth. So and we are giving 1 second to be our time. Okay? Then the second parameter is the velocity, which is 1500 meters per second. Then we are asked to find the depth, which is the same thing as distance, is unknown. So you can see the triune components here given. So learn this for better understanding. So using V is equal to 2D over T, what are we going to have by substitution? We'll now have 1500 is equal to 2 times D over 1. So from here we can cross multiply. Are you with me? So that you still have back your 1500. Let's indicate that cross multiplying 1500 multiplied by 1 is equal to 2D. Okay? So that 1500 multiplied by 1, you know, it will give you back your 1500 is equal to 2D. So let's divide through by 2. Are you following? So that our D will equal 1500 divided by 2 is 750 meters. Now, some of these questions you might be asked to leave your answer in kilometers. So this will give us 0.75 kilometers. Are you here? Now, for you to achieve this, you will divide 750. Okay? If you divide 750 by 1000, okay, you will achieve this to give you this answer that you are seeing. Alright, let's proceed further with this question. A man clapping his hands at irregular intervals observes that the echo of a clap coincides with the next clap. I hope you are following. So if the reflecting cliff is 160 meters away and the speed of sound is 320 meters per second, what is the frequency of the clapping? That's the question. So given parameters using the triune components or the triune methods, number 1 is the distance given to us to be 160 meters. Then number 2 of the triune components here is the speed given to us to be 320 20 meters per second. The number 3 is the frequency that is now unknown. What is the frequency of the clapping? Are you here? So F is unknown. These are 3 interconnected parameters, the triune components of this question. So with these, which of the formulas do you think we can use for this? So using F is equal to 1 over T from grade 11 physics, waves. So if we're going to find F, we need this formula. And if you observe, from F is equal to 1 over T, we don't have T. We don't have time. So we need to calculate for time using V is equal to 2D over T. Okay? To find T. Please take note of this so that we can substitute that into the formula above. I hope you are following. So let's begin now. We'll now use V is equal to 2D over T to begin to solve this. So let's do that properly now. V is equal to 2D over T, so that by substitution, our V is given to be 320. 320 is equal to 2 multiplied by our D is 160. 160 over T. I hope you are following. So from here we can cross multiply so that we now have 320 multiplied by T is equal to 2 times 160. I hope you are following this. So 320T is equal to 2 multiplying 160 will give us 320. Right here? So 320T is equal to 320. Divide through by 320. Are you here? We are dividing both sides by 320. So that 320, we cancel out this. So our T is equal to 320 divided by 320 will give us 1 over 1 and is equal to 1 second. So we'll now pick this 1 second, okay, and substitute into F is equal to 1 over T. So let's rule a line so that we can solve that now. So remember that F is equal to 1 over T. So now, since our T is equal to T in period and is equal to 1 second, then we can substitute that and say that F is equal to 1 over T, which is equal to 1 over 1, which is equal to 1 Hertz. So this is our final answer. If you are new to this channel or you are joining us, please subscribe and to get more. Next question. The sound from a source traveled to the bottom of the sea, and the echo was heard 4 seconds later. So if the speed of sound in sea is given to be 1500 meters per second, the depth of the sea is, so solution using the triune method. This method will help you to be able to solve these problems easily, please. Okay, the sound was heard 4 seconds later, so the first of the triune component, our time, is 4 seconds. Then our speed is given to be V is equal to 1500 meters per second, the second triune component, and the third is the depth, D is equal to unknown. You can see these are our triune components. With this, it can help you to use V is equal to 2D over T to solve this problem. I hope you are learning. So 1500 is equal to 2 multiplied by D over 4. Now from here we cross multiply, right? So that we have 1500 multiplying 4 is equal to 2 multiplied by D, which gives you 2D. If you have any question related to this, you can drop them in the comment section below so that we can help you out. So proceeding further, we know that 1500 multiplied by 4 will give us 6000 is equal to 2D. So dividing through by 2, so that 2 cancels out 2, then our D is equal to 6000 divided by 2 is 3000 meters. So this gives us our final answer to this question. Let's proceed with this question. A boy stands between two vertical walls and fires a rifle. Are you getting the gist? Question 1. Under what condition will he hear a single echo from both walls? Then question 2. Calculate the distance. Okay, let's use red. Calculate the distance between the walls if the single echo heard is 6 seconds later. So we are asked to take the speed of sound in air to be 330 meters per second. Solution: we are going to depict or interpret this question using some diagrams. Is that clear? So that we can solve this and to understand. So let's reuse this to represent the boy. Okay, a boy, but we're going to change this boy later. I don't like this image. So a boy stands between two vertical walls. So let's assume that this is one of the walls and this is the second wall. So he's standing in between the walls. Are you following? And remember, the question reads, let's change it, that the boy shoots a rifle. Okay, so that's a rifle there that he fires. I hope you're getting it, the one with an arrow. So under what condition will he hear a single echo from both walls? So if you observe, if you check this critically, you see that it has to be at the center of the walls, of both walls. So the position of the boy needs to be at the middle so that he can hear a single echo. But if he fails to be at the center, he is going to hear the echoes separately. I hope you are getting this. So the boy needs to be at the center. Let's adjust his position so that the distance will now be divided into two equal halves, because d plus d is equal to 2d, and 2d divided by 2 will give you d. I hope you are following. So let's write it now clearly for you to see. So he, the boy now, will hear a single echo. Are you here? You hear a single echo from both walls. From both walls. If that's the condition, he stands. Are you here? If he is standing, or if he stands in the center, the middle. Okay? Let's write that in bracket. The center. Can you see the boy now? Distance divided into two equal halves. The center of both walls. Are you getting me? The center of the distance between the two walls. Let's use that to represent this. Between the center of the distance between the two walls, so that dd is equal to d. Of course, because d is equal to d, they are the same. I hope you are getting it. So that when you add them up, it gives you 2d. Is that clear? So this gives us the concept of an echo. So let's solve the second one now. And we're going to extract our triune components, our data from the question. They say calculate the distance. So our d is unknown. Okay, so we're going to write that. And our time is given, the second triune component, and our speed is given, the third triune component. I hope you are following this. So you can see, always use the triune concept to solve mathematical problems under physics in order to achieve a better result. I hope you are getting it, to help you to be able to record the formulas properly. So let's depict this using a diagram. So if this is the same diagram, please. So we want to redraw the same diagram, distance between the two walls. So it has to be from the first wall to the second wall, please. Not from the wall to the boy. Okay? From the wall, one wall, to this next wall. That's what the question is asking us for. So it's like doubling your answer. Are you here? So this gives us the total distance between the two walls. But here we're using just D to represent that total distance. Right here. So can you see it now? So that D, we have D here, and we have D to my right. So that we have D plus D will give us 2D. I hope you're getting it. Let's return the boy. You can see him standing at the center. So what we're looking for is the total distance. Please subscribe to our channel if you are yet to do that, so that you will be getting latest updates as we are dropping them. So using V is equal to 2D over T, okay, this connects our triune components. Are you getting it? So it means we are going to solve for this D and the other D. V is equal to 2D over T. So whichever method you decide to use here, it solely depends on you, okay? But here I'm going to just use V is equal to 2D over T. Then I'll multiply my final answer by 2. I hope you are following. So whichever method, you can decide to solve this simultaneously, pick them and solve, combining them together, whichever method you want to use. So V is equal to 2D over T times 2. I've combined these two. I hope you are getting it. I hope you are getting my interpretation. This will make it easier for you to solve problems of this nature. So let's proceed further now. Please, I'm not going to use my 2 now. I'll use my 2 at the end of my workings or solution. So our triune component, our V, is given to be 330 meters per second. The second triune component as given, let's look at it quickly. The second triune component is our time. Our time is 6 seconds. So let's write it, T is equal to 6 seconds. Then the third triune component is what we are calculating for. And this is D, that calculate the distance between the walls. So this is meant to be DT, is unknown. Total distance is unknown, please. Okay? But we're going to use this as the initial distance to solve before the final distance. So let's substitute into V is equal to 2D over T times 2. Okay? Recall, I said I will use this at the end of this solution. So 330 is equal to 2 times D over 6 multiplying 2. So let's proceed further by cross multiplying. If we cross multiply this, so let's rearrange this and rewrite it. 330 is equal to 2D over 6 multiplying 2. Okay? So let's proceed further by cross multiplying. Are you here? So when we cross multiply, we are having 330 by 6 is equal to 2D. Okay? The whole of this will multiply 2. Is that clear? The whole of this will multiply 2 at the end. I'm not going to apply it now. Please recall that. So let's proceed further. 330 by 6 will give us 1980 is equal to 2D. Let's divide through by 2 so that 2 cancels out. 2D is equal to 1980 divided by 2 will give us 990 meters. But we can now apply our 2 now at this juncture. So D is equal to 990 multiplying 2 will give us 1980 meters. So this is a distance between the two walls. I hope this was clear. If you have questions, drop them below for solutions. Alright guys, this next question is under resonance in sound wave. So a wire is stretched between 2 points 1 meters apart. If the speed of the wave generated on plucking the wire is 200 meters per second, so what is the minimum frequency with which it resonates with the wire? Here, so solution to this question. Please check our channel for the full tutorial on this topic. Okay, this one we are solving problems. Remember the triune concepts. We're going to see 3 things that are similar here. The first is the distance stretched, so it becomes length. Distance is in meters, length is also in meters. So our length is equal to 1 meter. Is that clear? The first triune component. Then the second triune component here, for you to solve this problem properly, is the speed. The speed is given to be v is equal to 200 meters per second. Are we together? So the question is, what is the minimum frequency? That is, f is equal to unknown. Can you see the 3 triune components related? So we need a formula that can connect these 3 triune components perfectly. So in doing that, we'll now recall that, okay, under resonance, recall that L is equal to lambda over 2. We need to find wavelength, which is also known as lambda, for us to be able to find f, which is our frequency. So we'll make lambda the subject of the formula so that our wavelength will now equal 2L. I hope you are following. And this will now equal 2 multiplying 1, so that you have 2 meters as our wavelength. Are we together? Then we can now substitute this into using V is equal to F lambda, which is wavelength. Are we together? By substitution, our V is given to us to be 200 is equal to F multiplying 2. Okay? So that from here, what do we have? 200 is equal to 2F. So dividing through by 2, so that 2 cancels out 2, and our F is equal to 100 divided by 1 is 100 hertz. That's the solution to this question. Alright, let's proceed with this question. A note A from a guitar produces a wave of amplitude 4 millimeters and frequency 100 hertz. Another note B from a whistle produces a similar waveform of amplitude 2 millimeters and frequency 2200 hertz. So if the two notes are compared, comparing amplitude to frequency, that which of these options is correct? A has a higher pitch than B. A is louder than B. B has a greater speed than A. B is louder than A. A and B have the same quality. So, solution, if we want to solve this properly, we need to consider pitch, we need to consider intensity, we need to consider amplitude, and we need to consider the relationship with frequency. So, from what you've learned before, you would agree with me that amplitude and intensity are related. So if we use that mathematically using a particular formula, we'll write that, recall that intensity, okay, intensity is proportional to the square of amplitude. Are you here? Intensity is directly proportional to the square of amplitude. So this is a formula that will help us to be able to answer this question correctly. So it means loudness depends on the square, okay, of amplitude. Are you here? Loudness depends on the square of amplitude. So looking at the given parameters from here, you understand that if the two notes are compared, you can see that being circled, A and note B. If we compare them using the given parameters, for A the amplitude is 4, for B the amplitude is 2. So you see that 4 minus 2 is 2. So A is greater than B, okay? Yes, A is greater than B. So you can see that option B says that A is louder than B. Why? Because loudness, okay? Because loudness depends on amplitude. or the square of amplitude, please. So the difference here between A and B is 2 millimeters. Are you here? Alright, let's proceed with this question. A steel wire of length 0.50 meters is stretched between two fixed points and its fundamental frequency is 200 Hz. The speed of the wave in the wire is, that's the question. So recall solution given data using the triune concept, the triune components by relationship. From this question, you will see that number one, we have the length of the wire. So our L is equal to 0.50 meters. Number two, triune component. From this question, the fundamental frequency. So it's given to us to be our F naught is equal to F and is equal to 200 Hertz. Are you here? So the third triune component is what we're looking for, the speed of the wave in the wire. So our speed is known as our velocity and V is equal to unknown. Are you here? So with these we can proceed using the formula that will suit these triune components. So V is equal to F lambda. Recall that lambda is wavelength, okay? And it is measured in meters. So we don't have wavelength, hence we can look for wavelength using L. So we need a formula that can suit this. So L is equal to lambda over 2, okay? So lambda will now equal 2L. So with these we can solve for lambda and substitute into V is equal to F lambda. So V is equal to, are you here? By substitution, F. We'll write our F because it's given. So F multiplying our lambda. Instead of writing this lambda, we'll write 2L. Is that clear? So F multiplied by 2L. Are you here? So this will now equal 2FL. So V is equal to 2FL. Solving now, our V will now equal 2 into our F is given to us to be 200. Multiplying 200 times our L is 0.50 meters times 0.50. Here, so that our V will now equal 2 times 200 will give you 400. 400 multiplied by 0.50. Solving further, V is equal to 200 meters per second. I hope that was clear. Next question. A string is fastened tightly between two walls, okay, 24 centimeters apart. The wavelength of the second overtone is, that's the question. The wavelength of the second overtone is, so solution. Looking at this question, you know that is still under sound wave and is under resonance. Now, the given parameters from here is 24 centimeters apart. That is the length, 24 centimeters. Okay? Then, what again is given? The wavelength is what we are looking for. Okay? So, the wavelength of the second overtone is unknown. Are we together? So, for us to be able to find this wavelength, we need to apply our formula under this topic. So, recall that F naught is equal to, here is equal to V over 2L. If you have any question, you can ask them. So this will give us the first harmonics. Are we together? Now, the question is asking us for the second overtone. For us to get to the second overtone, then F1 will equal to F naught. Are you here? We can decide to use this option to save time. 2F naught. And this will give us the second harmonics. Are we together? So if that's the case, The question is asking us for the second overtone. So this second harmonics is the same thing as V over L. Are you here? So that F2 will now give us is the same thing as 3F0. Are you here? Not 3F1, please. 3F0. And this is the same thing as third harmonics. Are you here? Third harmonics. So if that is the case, third harmonics will equal 3V over 2L. Now this third harmonics is called second overtone, okay? Then the second harmonics is called the first overtone. Are you following? So now let's solve for this now. That's what we are looking for. So if we are solving for this, we might solve for F0 V over 2L, then substitute for F0 into 3F0. You have an option there, or you can decide to use 3V over 2L directly. So for second overtone, are you following? In case you have any questions, you can drop them in the comment section below. Let's proceed. L is equal to 3 wavelength over 2. Please, is 3 lambda over 2, not 3V. The V there represent lambda, please. So lambda is equal to 2L over 3. Okay, if you are making the supposed V there the subject of the formula, which is lambda. So now, if we have this, then we can solve this further. Lambda is equal to 2 multiplied by our L is given to us to be 24 centimeters. Okay, we are not converting at this level. 24 over 3 is equal to 48 over 3. So that we have 16 centimeters. Next question. All of the following frequencies are overtones of 320 Hz except they are overtone of 320 Hz except we have 960, 640, 520, 1280 and 1600 Hz. So we're going to solve using 320 Hz. Is that clear? Then in the options, we'll check which of these options is not correct. So if F0 is equal to 320 Hz, the fundamental frequency, then our 2F0 will equal 2 multiplying 320, okay, which will give us 640 Hz. Are you following? Then 3F0 will give us 320 multiplied by 3 will give us 960 Hz. Are you following? So 960 Hz. Then 4F0 is equal to 320 multiplying 4. This will give us 1280 Hz. So let's write that 1280 Hz. Then 5F0 now. 5F0 will equal 320 multiplying 5. Okay, this will give us 1600 Hz. So at this juncture, we're going to consider our options. So we're going to look at them one after the other for better understanding. For those of you that might not understand this concept, so let's look at 960 Hz. Okay, let's consider 960 Hz. We have 960 Hz here, 3F0. Okay, or 3FO. We have 960 Hz. Then 640 Hz, option B. We have it. Yes. Then 520 Hz. We don't have it. Can you see it? We don't have it. So automatically our answer becomes 520 Hz. Are you following? Then 1280 Hz. We have it. You can see that 4F0 or FO. Then 1600 Hz. We also have it as 5FO. So definitely our answer becomes option C. Okay, option C, 520 hertz. So in case you have any question, you can drop them below. So hence our answer is equal to option C. Next question. If two identical tuning forks with natural frequency 256 hertz, one is loaded so that 4 beats per second are heard when they are sounded together. So what is the frequency of the loaded tuning fork? Now here, so solution, given data, let's extract them now. Refer to our channel for full tutorial videos on sound waves. Now if two identical tuning forks with natural frequency, so two identical, we must have two frequencies here. So the one given here signifies F2. Okay, let's use F2 to represent it. F2 is equal to 256 hertz. Are we here? One is loaded so that 4 beats per second are heard. So 4 beats per second, let's write that. Our beats is equal to 4 beats per second. Are you here? Then what is the frequency of the loaded tuning fork? So you see that we need another frequency. So we'll use this to represent F1 so that we can calculate perfectly. Hope you are seeing it. So we'll represent that with F1 is equal to unknown. Hope you are here. So beats can be gotten when you subtract the final minus the initial. Okay, so recall that beats, okay, is equal to F2 minus F1. Okay, this will give us an idea of what we are doing or trying to solve. So 4 is equal to our F2 is 256 minus F1. Is that clear? So let's collect like terms so that F1 is equal to 256 minus 4. So that our F1 is equal to 256 minus 4 is 252 hertz. I hope this is clear to you. Alright, let's proceed with the next question. The lowest note emitted by a stretched string has a frequency of 40 hertz. How many overtones are there between 40 hertz and 180 hertz? So solution, our target here is to count the number of overtones between 40 and 180 hertz. So our frequency of 40 hertz is the lowest note emitted. So we call that fundamental frequency. So F0 is equal to 40 hertz. Now, how many overtones are there between 40 and 180? We'll keep on solving until we get to either 180 or a value above 180. I hope you are following. So the values between 40 and 180 is our target. So let's begin now by solving properly. If our F0 is equal to 40 hertz, then if F0 is equal to 40 hertz, then 2F0 will equal 2 multiplied by 40 will give you 80 hertz. 3F0, that is the method, okay? 3F0 is equal to 3 multiplied by 40 is equal to 120 hertz. Then 4F0 is equal to 4 multiplying 40 will give you 160 hertz. 5F0 is equal to 40 multiplying 5 is equal to 200 hertz. Then from here we can decide to solve further or stop because the target is 180. So between 40 hertz and 180 hertz, how many overtones do we have? There are, let's count now. Are you here? 40 and 180 between them, the number of overtones. So where is our 40? Our 40 is F0. Okay, our 180 should be above 160. So if our F0 is 40, then our 180 is before 200. I hope you are following. So the merging is between F0 and 5F0. Are you here? So we have 2F0, 3F0, 4F0. So we have 3 of them. 1, 2, 3. So hence our answer becomes 3 overtones is equal to 3 overtones. I hope you are following this. So if you have questions under this topic, you can drop them in the comment section below. Alright, next question. A sonometer wire of length 100 centimeters under a tension of 10 Newton has a frequency of 250 Hz. Keeping the length of the wire constant, take note of that, the tension is adjusted to produce a new frequency of 300 Hz. So the new tension is solution. Taking note of the triune components of this question are given data. The first is length of 100 centimeters. So our L is equal to 100 cm. You can decide to convert these to meters, okay? By doing so, you divide 100 by 100, which will give you 1 meter. Exactly. Let's go ahead to do that. 100 divided by 100 is equal to 1 meters. Okay? Then, let's proceed further with our triune component. What again is given? Under a tension of 10 Newton. So you can see that our tension is given. So, if our tension is given and they are asking us for a new tension, then of course you know that we'll have two different datas. Okay? So, the tension of 10 Newton will represent that to be T1. Hope you are getting this. I'm cycling them so that you understand that we are asked for another tension. So we need two tensions. So T1 is equal to 10 Newton. Then T2 will be unknown. Exactly. But we'll write that later. So let's proceed further. The third of the triune component given to us is the frequency of 250 Hz. So, and a new frequency of 350 Hz is given. Hence, the 250 becomes F1. Okay? So F1 is equal to 250 Hz. And then our F2 will be 350 Hz. So the new tension is T2, which is unknown. Then F2 is equal to 350 Hz. I'm taking them this way so that you understand vividly what we are doing here. F2 is equal to 350 Hz. When you are solving these problems, you should be able to extract the given data for you to be able to solve perfectly. So recall that in a sonometer, okay, that F is equal to K, which is our constant, square root of T over M. Okay, so this is the formula we're going to use. Now if you check the question, something is given to be constant. Exactly. So you need to understand that this is the formula that will suit this given data, where K is equal to 1 over 2L. Are you here? That's our constant. Our constant is 1 over 2L. Okay? Now let's look at the equation. Keeping the length of the wire constant. So the length of the wire is constant. Keeping other quantities constant. So F is directly proportional, okay, to the square root of T. M is gone, K is gone. Is that clear? So, solving further, F when I equal K square root of T. Okay? But remember that we need to keep other quantities constant. So making K our constant is subject of the formula. It gives you F over square root of T. I hope this is clear. So we are going to be equating K to K, constant to constant, which will give you F over square root of T is equal to F over square root of T. Exactly. That is the only way we can solve this problem, because we're having T1 and F1 and T2 and F2. Is that clear? So let's equate the two now. So K is equal to K. K1 is equal to K2. Okay? So F1 over square root of T1 is equal to F2 over square root of T2. This will suit our datas. So by substitution, our F1 is given to be what? Let's look at it. Substituting. F1 is 250, right? So 250 hertz. Let's write that. 250 all divided by square root of T1 is 10 Newton. So we have 10 is equal to F2 is 350, right? 350 hertz. So 350 divided by square root of T2 is unknown. So square root of T2. Are you here? So from here we cross multiply so that we have 250 multiplying square root of T2 is equal to 350 times square root of 10. Is that clear? So our target is to solve for T2, not square root of T2. So we can decide to divide through by 250, right? So let's exhibit that. So we divide both sides by 250, so that 250 will cancel out 250. Then square root of T2 is equal to 350 root 10 over 250. Exactly. But we're looking for T2, not square root. So we're going to square both sides so that the square root on T2 will disappear. So take the square. Let's rewrite it. Square both sides. If we do that, so square root of T2 is equal to 350 times root 10 all over 250, all squared, and then all squared also. Yes, let's do that. So with this, you know that this will cancel out this. Then T2 is equal to 350 squared times 10. Yes, this will cancel out that all over 250 squared. Exactly. So this is what we're having. So that T2 is equal to 350 squared will give us 350 squared. Let's write it. Will give us 122,500 multiplied by 10 all divided by 250 squared. 250 squared will give us 62500. Okay, so that T2 is equal to 122,500 times 10. Of course, 10 will be added. So we have 122,500 divided by 62500. So that if this divides this, let's do that and see. Our answer will become 19.6 Newton. Are you here? 19.6 Newton. So drop your questions. Next question. It goes, a string of length 1.0 meters vibrates in 10 loops. Okay, if the total mass of the string is 1.0 times 10 raised by 3 kilograms and the tension in it is 10 Newton, then calculate the frequency of the vibration. So solution, the given data from here, our length is given to be 1.0 meters, okay? Then what again is given? Vibrates in 10 loops. So number of loops is given to us. We'll not use this now, we use it at the end of our solution. Okay, so number of loops is 10. Exactly. Take note of this. We're going to use it to multiply by our frequency later. So number of vibrations, which is loop, is equal to 10 loops. Exactly. So total mass of the string is given to be 1.0. So let's write that. Our mass is equal to 1.0 times 10 raised by minus 3 kilograms. And the tension in it, so our T is given to be 10 Newton. Let's write that. 10 Newton. So calculate the frequency of the vibration. So that's where the problem lies. So F is equal to unknown. So we need a formula that can connect these data. So using F is equal to 1 over 2L multiplied by the square root of T over M. We'll be able to solve this problem using this formula. Is that clear? So F is equal to, okay, can you see that? 1 all over 2 multiplied by L. Our L is 1.0, so multiply by 1. Okay, then multiplied by the square root of T. Our tension is 10 all over M. Our M is 1.0. Okay, 1.0 times 10 raised by minus 3. Are you following? Times 10 raised by minus 3. So solving this further, our F, let's rewrite this please. Square root of 10 all over 1.0 times 10 raised by minus 3. Are you getting the gist? So from here, our F will now equal 1 over 2 multiplied by the square root of 10 divided by 1.0 times 10 raised by minus 3 will give us 10 raised by 4. Are you here? So that F is equal to 1 all over 2 multiplied by the square root of 10 raised by 4 will give you 10,000. The square root of 10,000 is 100. So 100 times 1 is 100 divided by 2, and to give you 50 hertz. I hope you are following. So this becomes our frequency, 50 hertz. Now they are asking us, or they give us a particular value, and they said that it is 10 loops. Okay, for a single loop we have 50 hertz. Exactly. So if we multiply that, now since it vibrates in 10 loops, okay, they will now multiply 50 by 10. Exactly. So F is equal to 50 times 10 and is equal to 500 hertz. That becomes our final answer. Next question. The fundamental frequency of a blocked node under a tension of 400 Newton, underline that, is 250 hertz. When the frequency is changed to 500 hertz at a constant length, the tension is, so this question is asking us for the tension, and if you observe, using the triune component, the given parameters from here, Number one, you will see that we have the fundamental frequency given to us to be 250 hertz. So we'll write that. If you look at the question, we have another frequency. Frequency is changed to 500 hertz. So that becomes our F2. So quickly, F1 is equal to 250 hertz. Then alongside F1 is tension of 400 Newton. T1 is equal to 400 Newton. Okay. Then what again is given? The frequency is changed to 500 hertz. So we have 500 hertz as your F2. Is that clear? Then our tension T2 is unknown. Is that clear? T2 is unknown. If the length is constant, then you know that L is constant. So this will help us to be able to use the appropriate formula for this. So using, are you following? Using frequency divided by the square root of tension, then we can say that F1 divided by the square root of T1 is equal to F2 divided by the square root of T2. Okay, this is a relationship we're going to use to solve this problem at this time. And you see that we have the triune components to be frequency, tension, and length being constant. So F1 is 250 divided by the square root of T1 is 400 is equal to F2 is 500 divided by the square root of T2, because that's what we're looking for. So cross multiply from here. What do we have? We now have 250 multiplied by the square root of T2 is equal to 500 multiplied by the square root of 400. Are you here? So our goal is to make T2 the subject of the formula. So divide through by 250. 250 cancels out 250. Then you are left with the square root of T2 is equal to 500 multiplied by the square root of 400, all divided by 250. Is that clear? Something is missing from here. We have not squared that T2. So let's insert the square root. Okay. So now the next step from here, we'll take the square root of both sides. Take the square root of both sides, or you say square both sides. Are you here? So that square root of T2 all squared is equal to, open bracket, 500 by here multiplied by the square root of 400 all divided by 250, close your bracket, squared. Is that clear? So that this squared will cancel out the square root. Then T2 is equal to, okay, then 500 squared, okay, multiplied by 400. Yes, you can see that, all divided by 250 squared. Is that clear? So we have expanded or removed the bracket there. So let's proceed further. So that T2 will now equal 500 squared will give us 250,000 multiplied by 400 all divided by 250 squared will give you 62,500. So that by further expansion, T2 will equal 250,000 multiplied by 400 will give us 100 million. Are you following? 100 million all divided by 62,500. So T2 finally, if you divide 100 million by 62,500, T2 will equal 1600 Newton. That's our final answer. Next question. A transverse wave is applied to a string whose mass per unit length on the line that is 3 times 10 raised to the minus 2 kilograms per meter. If the string is under a tension of 12 Newton, the speed of propagation of the wave is, so solution. Quickly, we want to extract the triune given parameters. Are you here? So that you'll be able to solve this problem properly. The first, if you observe, is the mass per unit length given to us to be 3 times 10 raised to the minus 2. Okay, so with this we have our tension also given to be 12 Newton. So let's write that of mass. M is equal to 3 times 10 raised power minus 2 kilogram per meter squared. Okay, then the second triune component of this equation is the tension. So our tension is given to be 12 Newton. Can you see that? So we write T is equal to 12 Newton. Then the third of the triune component is the speed of propagation of the wave. So our V is unknown. Now let's look for a formula that will best suit these triune components. So using, okay, V is equal to the square root of T over M. Now if you observe, our triune components are captured in this, so that V is equal to the square root of T. Okay, now T is 12 divided by our M is 3 times 10 raised power minus 2. Square root, please. Okay, then let's resolve this so that our V will now become the square root, okay, of 12 divided by 3 times 10 raised power minus 2 will give you 400. Is that clear? So that V is equal to the square root of 400 is 20 meters per second. That is the solution to this question. Ladies and gentlemen, let's continue with this question. The note produced by a stretched string has a fundamental frequency of 400 Hertz. Now, if the length of the string is doubled, that's a catch, while the tension in the string is increased by a factor of 4, then the frequency is unknown. So solution, we would want to extract the given triune components from this question. Okay, so fundamental frequency of 400 Hertz, F1 is equal to 400 Hertz. Then if the length of the string is doubled while the tension in the string is increased, so length now is a second triune component. So if we are having length that is doubled, then of course you must have the original length. So L1 will equal L. I hope you are getting this. Now, then L2 will now become 2L because it is doubled. Are you following? But the two L's are length, okay? The second triune component. The third triune component is tension in the string increased by a factor of 4, meaning we're still going to have T1 to be T, and then T2 to be 4T. Are you following? So you can see that our triune components are complete. The frequency F2 is unknown. So we have frequency, we have length, we have tension, the triune components of this question. So using these formulas, F is inversely proportional to length and frequency is also directly proportional to the square root of tension. So combining these two formulas or equations, we obtain a singular formula that we can use in solving this question. So combining F and F together, so that I have F is inversely proportional to length, okay, and times the square root of tension. Is that clear? Now combining this further, we have F is directly proportional to the square root of tension and is inversely proportional to length. So we'll bring in our constant now so that we can make constant the subject of the formula. So F is equal to K square root of tension over length. So making K the subject of the formula from here, K is equal to FL, okay, all divided by the square root of tension. So this is the formula that will suit our triune components given in this question. Is that clear? So that we have K is equal to K, meaning K1 is equal to K2. By expansion and substitution, what do we have? K is FL over square root of T. Okay? So let's write that now. So that we have F1 L1 all over the square root of T1 is equal to F2 L2 all over the square root of T2. Please, if you have any question, you can drop it in the comment section down below. Okay? Don't forget to subscribe and like this tutorial for further updates. Now substituting, our F1 is given to us to be what? Let's look for it. Our F1 is 400 Hertz. So let's write that 400 multiplied by L1 is what? Is L. Can you see it? Multiplied by L, all divided by the square root of T1 is T. Okay? So the square root of T. That's what we're going to write. Okay? Then F2 is unknown. So write that as F2. Okay? Multiplied by our L2 is 2L. So write that 2L, all divided by what is our T2? 4T. Okay? 4T. So we're going to substitute 4T for T. So square root of 4T. Is that clear? So solving this further now by cross multiplying. Okay? Then we'll have 400L. Okay? 400L multiplied by square root of 4T is equal to F2 2L multiplied by the square root of T. Is that clear? Now, here, we're going to be dividing through by 2L multiplied by the square root of T, so that F2 will be made the subject of the formula. So we're doing that now, divided by 2L square root of T, so that this will cancel out that. Then what are we left with here? We are left with F2. Okay, let's write it properly now. F2 is equal to 400L, right? So 400L multiplied by the square root of 4T, all divided by 2L multiplied by the square root of T. Okay? From now, let's reduce our values. Okay? We have 2 into 400 is 200. Then L will cancel out L. Okay? Then if you expand square root of 40, you can have square root of 4 multiplied by the square root of T. Okay? So that square root of T will cancel out square root of T. I hope you are following that. So let's do that now. So square root of T will cancel out the square root of T here. What is left? The square root of 4. So multiply by the square root of 4, all divided by 1. Is that clear? But of course, we are not bringing in 1 again. So let's solve further now. Let's solve further. We need space, please. So 200 multiplied by the square root of 4. Now, what is the value for the square root of 4? F2 is equal to 200 multiplied by 2. Okay? So that F2 is equal to 400 Hertz. So this is our answer to this question. Thank you. Hello guys, let's continue with this question. A piano wire 0.5 meter long has a total mass of 0.01 kilogram and is stretched with a tension of 800 Newton. So the question is, calculate the frequency of the wire when it sounds its fundamental note. So solution. Let's begin to extract the triune given parameters. Of course, here we are given 4 datas, but 3 are given to us. So the first is the length of the wire, 0.5 meters. Is that clear? Then followed by our mass, total mass of 0.01 kilogram. So M is equal to 0.01 kg. Is that clear? And it is stretched with a tension of 800 Newton. So that is our force, which is tension, 800 Newton. Is that clear? Then calculate the frequency of the wire. So our F is unknown. Now, the formula to be used here will be using, okay, F is equal to 1 over 2L, okay, multiplied by the square root of T over M. Are you following? This formula will suit our datas, so that F will now equal 1 over 2 multiplied by our L is 0.5, okay, multiplied by the square root of tension tension is 800 Newton, okay, all divided by our mass, 0.01. Is that clear? So from here, F is equal to, please subscribe and drop your questions if you have any. Now, F is equal to 1 over 2 multiplied by 0.5 will give us 1, right? So we're going to have 1 divided by 1. I hope you are here. So 1 over 1 multiplied by the square root of 800 over 0.01. So 1 divided by 1 is equal to 1. And 1 multiplied by the square root of 800 divided by 0.01 will still give you back the square root of 800 divided by 0.01. Is that clear? So F is equal to the square root of 80,000. In solving physics question, first read the question, understand the question, then extract the given data. In this channel, we are using the Triune methods. With that, you sort for the formulas that could connect or can connect the given data. And with that, you'll be able to have an idea on how to solve that particular physics question. So finally, for this question, our frequency will equal 283 Hertz. So that becomes our final answer to this question. I hope everything was clear. Next question. A pipe closed at one end is 1 meter long. The air in the pipe is set into vibration and a fundamental note is produced. If the velocity of sound in air is given to be 340 meters per second, calculate the frequency of the note. So solution. The given data, the triune components of this question. Number 1. A pipe closed at one end is 1 meter long. Are you here? So our L is given to be 1 meter. Please note that this question is under closed pipe at one end, please, not both end or open pipes. Then our L is equal to 1 meter. Then our velocity is given to be 340 meters per second. So V is equal to 340 meters per second. Okay? Then calculate the frequency, the third triune component. Our F is unknown. So our F is unknown. And this F will represent our fundamental frequency. Okay? So using F, here, F naught is equal to V over 4L. Now, why are we using 4L? Because it is closed at one end. And the whole of 4L is gotten from V is equal to F lambda. So the lambda there, which is wavelength, is the same thing as 4L. Are you here? So by substitution, F naught is equal to, our V is 340, all divided by 4 multiplied by our L is 1. So 4 multiplied by 1 is equal to 340 divided by 4, and is equal to 340 divided by 4 will give you 85 Hertz. So that gives us our final answer. Thank you. Guys, here's another question. An open pipe closed at one end produces its first fundamental note if the velocity of sound in air is V and L, the length of the pipe. The frequency of the note is given to be. So solution, the given data from these, you observe our velocity of sound is given to be V. That is our first triune component. So V is equal to V. Okay? Then our length is given to be L. So length L is equal to length, of course, in meters. Okay? Then the frequency of the note is unknown. So F is equal to unknown. So from these given data, what formula do you think we can use? So we need a formula that can connect the three data. So F naught is equal to V over 4L. Can you see that? Our triune component are embedded into this. So by substitution, our F will now become F naught is equal to, our V is given to be V, right? Is equal to V. by substitution. Okay, all divided by 4 multiplied by our L is given to be L. So multiply by L by substitution. So this gives us our final answer. Next question. An organ pipe closed at one end is 80 centimeters long. Determine the frequency of the fundamental note, assuming that the speed of sound in air is given to be 340 meters per second. So solution. The given data from these, the triune components. Number 1, our length is given to be 80 centimeters. So 80 cm is given to be our length. But remember, we're going to convert it to meters. So let's do that now. In converting to meters, we say 80 divided by 100, which will give us 0.8 meters. Okay, that becomes our length. Then we are given our speed. And then we are asked to find frequency. So determine the frequency. Our FO, or fundamental note, is unknown. Then the speed of sound in air, our V, is equal to 340 meters per second. So with these given data, which of the formulas do you think we can use to solve this problem? So we'll look for a formula that has the triune component. So F naught is equal to V over 4L. We're here. So 4L has replaced wavelength in this question. So F naught is equal to, our V is 340, all divided by 4 multiplied by 0.8. So that we have 340 divided by 4 multiplied by 0.8 is going to give us 3.2, right? So we have 3.2. Don't forget that this pipe is open at one end. Okay, this question is under sound waves. So 340 by 3.2 will give you 106.25 hertz. So this gives us our final answer. Let's solve this question. A pipe of length 45 centimeters is closed at one end. Calculate the fundamental frequency of the sound wave generated in the pipe if the velocity of sound in air is given to be 360 meters per second. So solution. Let's extract the given triune parameters or data. The first, our length is given to be 45 centimeters. We need to convert that to meters. So L is equal to 45 centimeters. Okay, then divided by 100 to give you 0.45 meters. That's our L. So L is equal to 0.45 meters. We're together. So with these, the next given data or parameter is the velocity. V is equal to 360 meters per second. Okay? Then they are asking us to calculate for the fundamental frequency, F naught. So that's the triune component. The third, F naught is equal to unknown. So with this, using F naught is equal to V divided by 4L, because length is given to us instead of wavelength. So the whole of 4L is our wavelength. So F naught will now equal, our velocity is given to be 360. So by substitution, 360 divided by 4 multiplied by our L is 0.45. Okay? So this gives us 360 all divided by 4 multiplied by 0.45. Okay? So we're going to have 360 divided by 1.8. Okay? So if you punch your calculator, F naught will now equal 360 divided by 1.8 is going to give us our final answer to be 200 hertz. So that will give us our final answer to be 200 hertz. So that's it for this question. Please, there are more solutions to problems under our sound wave. Check our channel for that. Welcome back to the Triune Physics, aka Physics Bible. Today we'll continue with questions on the sound waves. A pipe open at both ends produces a fundamental note if the velocity of sound in air is uppercase V and uppercase L, the length of the pipe. Which of the following expresses the frequency of the note? Neglect and correction. So these are our options. So solution, we are going to extract the given data over here so that we can connect our solution to the right option. So the velocity is given to be V. So V is equal to V in meters per second, of course. Then our L length is L, of course, in meters. Exactly. So L is equal to L. Let's write that properly. Then the question says express the frequency. So that's the triune component of this question. Frequency, velocity, length, frequency, unknown. So we're going to make frequency the subject of the formula so we can find the right option as displayed. So let's pick a particular formula that could connect these three parameters. So recall that F0 is equal to V all divided by 2L. Okay, this is for an organ, okay, opened, an organ pipe opened at both ends. I hear open at both ends. We're going to use this to solve that problem. So with this, if we substitute now, you will see that the right option is B, V over 2L upper cases. Alright guys, a tuning fork of frequency 340 Hz vibrated just above a cylindrical tube of height 1.2 meters. If water is slowly poured into the tube, at what minimum height will resonance occur? So take the speed of sound in air to be 340 meters per second. So solution, extracting the given triune parameters. So let's begin with the first, a tuning fork of frequency 340 Hz. So our F is equal to 340 Hz. Then cylindrical tube of height 1.2 meters. So our height, which is the same thing as length, okay, is equal to 1.2 meters. Can you see that? 1.2 meters. So let's write that. 1.2 meters. Okay. Then what again do you think is given here? We also have the minimum height. Will resonance occur? So let minimum height at which resonance will occur be L prime, okay, and is equal to unknown altogether. So with this, we can proceed further because our speed is given to us. So our speed is 340 meters per second. So using F is equal to V over 4L, right here, we're going to be using this formula to continue to calculate until we are going to obtain our value. Exactly. So if we are making L the formula, our L will equal V divided by what? 4F or F4, anyhow you're going to put it. 4F. So we're going to be using this to be calculating for our length or height. Is that clear? So let's begin by substitution. L1 will equal V over 4F, and our V is given to be what? 340. So allow me quickly to extract our V. V is 340, so that 340 divided by 4 multiplied by 340, that's our F, will give us 340 divided by 4 multiplied by 340 will give us what? 1, to give us 1360, and 340 divided by 1360, if 0 cancels 0, you have 34 divided by 136, so they have 0.2 meters. Exactly 0.25 meters rather, altogether. So we're going to proceed now with L2. Let's solve for L2 now. L2 will be equal to 3V. Okay, since we are solving for these, we are not going to be using V over 4F, but 3V over 4F. Okay, and it's equal to 3 times 340 divided by 4 multiplied by 340. Okay, so that 3 multiplied by 340 will give us 1. Okay, to give us 1020 divided by 4 multiplied by 340 will give us 1360, and 1020 divided by 1360, if 0 cancels out 0, you have 102 divided by 136, so your final answer becomes 0.75 meters. Is that clear? So let's proceed further. We'll not stop here. I want to show you something in the end. L3 is equal to 5V divided by 4F. Okay, so this becomes 5 multiplied by 340 divided by 4 multiplied by 340, so that 5 multiplying 340 will give us 1700 divided by 1360. Are you here? So that 0 cancels out 0. 170 divided by 136 will give us 1.25 meters. Now we're together now. So with these, we can be able to compare our datas. We have L1, we have L2, we have L3, 0.25, 0.75, 1.25. You can see that 1.25 is above 1.2 meters as given from the equation. Are you getting it? So let's calculate 1.25, compare it with 1.2. Can you see that? Then with this, we want to know the minimum height, which is L prime. Exactly. So for us to obtain L prime, we will now say that L prime, which is the minimum height, will be our L1, or the original length, minus L2. Are you here? Because if you compare L3 with the original length, you see that L3 is greater than the original length, 1.2. So I'm not going to use L3, but it's going to be 1.2 minus 0.75, which is L2. Since L2 is below the original length, then we have 1.2 minus 0.75. And 1.2 minus 0.75 will give you 0.45 meters. This gives us our final answer. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.